All right. So the third type of DI method type of question that you will run into is when a row in the DI chart repeats the original integral. So we're going to keep in mind this original integral right here. Now, here's the thing. E to the x, right? It's its own derivative and its own integral. Sine x is going to pop from sine x to cos x, back to sine x, back to cos x. So there's a good chance that we may see in this chart a row that's the exact same. So we're going to keep that open, our eye open for that, and that's what we're looking for. So again, let's use the Lie8 indicator for which one would have the preference for derivatives. I see this one is exponential, so that's kind of near the last. And this one is trig. Okay, so the trig one should go in the derivative spot, looks like. So I'm going to put sine x right here. And I'm going to put e to the x right here. The other thing you want to do in your chart is to put the plus minuses there, right? Plus minus, plus minus. And put 3 or 4 rows down there so we don't forget that. All right, so the derivative of sine x is? It's cos x. That's right. The integral of e to the x is? E to the x. Nice. Let's go back to the D column. The derivative of cos is? Okay, sine x, negative. And the integral of e to the x is still e to the x. Love that e to the x. Don't you love that e to the x? Love that. Love it. Love it. Okay, now what I notice here, e to the x sine x, I have it right here, e to the x sine x. Forget about the sine, because constants don't matter. We can put that out front, outside the integral, but do you notice that this is the same integral as we started with in our question? You see that? So this is good. And let me show you the little difference we need to do to complete this. So we are still going to do this. Sine x times e to the x is going to be our first term. So part of the solution here is e to the x sine x. Okay, that's awesome. And we'll go down to the second row. Minus e to the x cos x. Minus e to the x cos x. Okay, that's great. Now I see I have this integral. So guess what? I'm actually going to just rewrite the integral as I see it. Oh, sine x dx. Okay, I'm trying to leave some room here. So minus sine x dx. Okay. So at this point, you're saying to yourself, well, Mr. Maxwell, this actually is not an easy derivative to solve. I'm not sure why we're rewriting this, but watch what this can look like here. Okay, I'm going to just move some stuff around, and I'm actually going to rewrite the original question here, which was the integral of e to the x sine x. Now we have simply rewritten what this integral looks like, and we do have this pesky integral over here that's not easy to integrate, but because it's the same, and something happened here. Oh, weird. Disappeared on me. Integral sine x e to the x, or e to the x sine x.
Are we doing another integration by parts?
No, sorry. This disappeared on me. So I had something disappeared on me, glitch in the system here. So this, I just rewrote this integral, right? That's true. And then the negative sign is out here. There was a negative sign in there too. Sorry, some glitch in the system here. All right, so okay, here you go. Look at this. I can now combine like terms. So I'm actually going to add this integral to both sides. I'll speed up here now. I'm going to add this integral to both sides. And what do I have? Well, I have now 2 integral e to the x sine x dx equals e to the x sine x minus e to the x cos x. And then these are gone now. Okay. So what was I trying to find? I was trying to find an explanation here, a simplified explanation or a description of what this integral is, right? What does this integral equal? What's the simplified version? Well, if I just divide both sides by 2, because I have 2 of these, I divide both sides by 2, then what I'm left with over here, e to the x sine x dx is actually equal to this right here plus c. So this is my answer right here. Okay, so this is kind of where we were before. So do you see how I do have what this original integral equals? So when a row on your DI chart repeats, that means you can rewrite it, and it's going to, I should say, repeats as the exact same as the original question, right? Then you can show that in your final, in your determination here, and then you can actually gather like terms, which we're actually, now we have 2 of these, divide by 2 to get rid of this 2, and there you go. That's the way you can isolate that. So it's kind of some mathematical sleight of hand there, really. It seems like, oh, I've never seen that before, where I have the original question as part of my answer, and I just sort of like combine the original question with part of the answer. Yeah, well, we just did that. So, and that's valid. So that is type 3. Got it? A row in the DI chart repeats the original integral. And if you see that, like I noticed right here, you write it out, gather kind of like terms here, right? Like terms in air quotes. Divide out our constant, add a c, and we're done. Questions? No questions?